Alright, welcome everybody to week 13, day 2. Very happy Wednesday to all of you. There is one more cognitive bias that I want to talk about, and this is called motivated reasoning. And this underlies a lot of fallacies, a lot of mistakes people make, a lot of bias you'll see in the world. And what it is when you have an existing belief, you want that belief to be true. And you'll seek out evidence to support your belief. And that's not good. The way that these things should work is that you should take evidence and build a belief from it. Instead, it's a very human thing to do. You have something that you believe, you seek out evidence, and you find evidence that supports your pre-existing belief. And that's probably the root cause for cherry picking, right? Bernie Sanders wants his vision of democratic socialism, whatever that means, to be true. So he will cherry pick out examples of where capitalism doesn't work and says, see, this is why democratic socialism must work. Christians look for arguments to support God existing, and says, there's the reason why I believe in God. Atheists do the same for arguments against God. But it's emotional reasoning. It's not intellectual reasoning, right? Because you're just selecting things to confirm what you already know. So you can call that confirmation bias as well. And personally, when I was growing up, I was a child of the 80s, and there's this TV show called The Cosby Show, which was it is like cherry picking, but it's the root cause for cherry picking. So remember, cognitive biases are the shortcuts or heuristics that the human brain takes that underlies fallacies, right? And so motivated reasoning is the notion we seek out things to confirm what we already know. Confirmation bias. We look for examples to support what we believe. We look for arguments to support what we believe, rather than the other way around. It's actually oftentimes hard to convince somebody that they're wrong, because they will find one example of like somebody on YouTube saying that they're right, and then they'll stick to that. They're like, look, there's evidence for my belief, and that's like, that underlies a lot of like the anti-vax stuff, right? If you're an anti-vaxxer and you believe vaccines are bad for you, and you find somebody on YouTube that talks about, I don't know, like a story of like when he tried reporting something on VAERS, the Vaccine Adverse Event Reporting System, VAERS, VAERS, and it didn't work, because there are issues, I would say, with VAERS, like in how they do it and how they decide if something's a adverse event or not. There's reasonable criticisms you can make of the system. The anti-vaxxer would be like, see, that's why vaccines are bad. I found something to confirm my beliefs. And so it underlies, motivated reasoning is a very powerful thing. It's very, very powerful. None of us want to be wrong, right? We all want to feel intelligent. We all want to feel good about ourselves. None of us want to be wrong. And so it's very hard to convince somebody that they're wrong. Because if we were rational creatures, I'd be like, oh, yeah, the evidence says I'm wrong. You're right, I'm wrong. And if you've ever had an argument with somebody on the internet, that basically never happens, or it's very rare. Or the evidence has to be so overwhelming that they go, oh, okay, you're right. Yeah. What if you want to be wrong? Yeah, some people. So, in the news right now, you have the Kyle Rittenhouse thing. I wonder if they have a... see if there's any news on that. Yeah. Okay, so the jury is still in deliberations on the Kyle Rittenhouse thing, and it was interesting watching the news, watching the media as that split along party lines, which it shouldn't. The facts are the facts. There's extensive video footage of like amazing amounts of video footage, like basically everything that the trial is about. Like there almost shouldn't even be a trial, in my opinion, because you can just sit there and play the videos and be like, all right, here's what happened, and then let the jury make a decision. Like, was it justifiable self-defense or not? There's no question that Kyle shot and killed 2 guys and shot and wounded a third. Like the basic facts are there. You know, there's some disagreement over you know, some minor points, but basically there's pretty extensive video evidence of everything. But if you look at like the news reporting over it, CNN and MSNBC, which are more left-leaning news outlets, have been negative on him. Fox sees him as a hero for the right, so they've been very positive on him, and it's disappointing. It's disappointing to see the media, who are supposed to be journalists, who are supposed to be impartially presenting the facts, so predictably saying, you know, what their base wants them to say. Yeah. And it's the absolute state of the media in our country where, like, you can almost, without even, like you almost can predict what they're going to say, you know. And because, you know, Kyle Rittenhouse is it's somehow political football, and because Kyle Rittenhouse is supported by the right, then the left has to oppose it, and vice versa. Because he was on the streets during rioting, supporting the Black Lives Matter movement, then that makes him automatically a white supremacist, and so it became political, and so it's motivated reasoning underlines all of that, right? If you're right wing, I want him to be innocent. If you're left wing, I want him to be guilty. And a lot of people didn't even look at the facts, like he's just clearly guilty or he's clearly innocent. And yeah, what you should do is look at the evidence. You know, there's plenty of primary footage. It's 2 minutes long. You can watch the whole thing yourself, and you can decide for yourself, was it justifiable self-defense for Kyle Rittenhouse to shoot those 3 people? You know, and it's disappointing how little of that I see. I have seen some of it. I have seen some in online conversations of people like examining the data and like actually going through it and trying to figure out, okay, is there an exception? You know, does Wisconsin, is there an exception to self-defense, right? In some states you have what's called a duty to retreat, where if you have the ability to get away, then you can't claim self-defense if you could get away. And Wisconsin doesn't. Okay, all right. Does it have, you know, stand your ground? You know, and so I've seen some people working through it, but it's really disappointing how few do, and they just repeat, I'm left wing, so he must be guilty. I'm right wing, he must be innocent. You know, they don't say that, but you know. Yeah, guilty. Yeah. So, yeah. So basically, my advice for everyone is just be aware of your own biases. You know, if you're left wing or right wing, just be aware that you're going to have a predilection on this trial. And just to be aware of that, and that it can shape your opinion of the evidence and conclusions that you draw thereof. And avoid just saying that you agree with something or disagree with it because you have a predisposition to, you know, just because, you know, if you're a Fox News watcher, you know, if you're a CNN watcher, well, CNN told me it's true, it must be true. Nah, they both can't be true, right? So that's motivated reasoning, very powerful thing, and just pay attention to that. It underlies a lot of the fallacies we've studied in this class. Where the peer reviews are always due 1 week after the original thing. After the original deadline. Okay, so we're now going to be moving into the last major topic we need to cover as far as critical thinking goes. Hello, what'd you miss? We just talked about the Rittenhouse trial and motivated reasoning. So you can watch the 2 minutes. Finals. Yeah. Yeah, you missed the final. um, so we will talk about the final essay, but maybe not today. We need to get into set theory. So, so there's still lots of points available in the class. 30% of your grade is still completely up in there. So if you're like, look at my grade, it's not good. Just be aware that if you do the final essay, well, that's like a whole letter grade you'll pick up. That's cool. And then the final is worth as much as the 2 midterms, which is traditionally what students in this class do the worst on, because it's one thing to sit there and agree with your professor when he talks about invalid, valid, and sound. It's another to have to do it on your own. Right? So, yeah. So you've had plenty of practice at it now. We'll practice more before the final comes up. All right, so we're talking about set theory. Set theory is really important. If you're going to be a computer science major, if you're not going to be a computer science major, it doesn't matter. It's very, very important. At the most basic level, what is the set? What do we mean by set? What do we mean by set theory? It's just a collection of elements. Not elements like iron and copper and hydrogen and helium and lithium, beryllium. No. Elements can be anything. And this is an object, right? And so I could have a set. I can declare a set right now to be the set of all remote controls that are on my desk. And it would include these 2 things right here. This is for my AC. I got a wall-mounted unit. This is for my speaker system. Okay. And that's it. Okay. So the set of all remote controls on my desk would have those 2 things and nothing else in it. Those 2 elements and nothing else in it. And you can basically make a set however you like. We'll get into some exceptions to that. But yeah, don't try and BS your way through this essay. It's just spend a little time on it, get it done. It'll be fine. I'm a pretty lax grader. Well, that's not exactly the right way of saying it. I grade exactly as I tell you on the rubric, So, yeah. Okay. I don't just like sort of arbitrarily mark people down though. If you do the work, you do what I ask you to do, you get an A. It's pretty straightforward. Most people that fail this class do so because they didn't do the peer reviews or didn't take any of the daily quizzes ever, which happens. So, yeah. In general, a good policy for life, Joanna, is try to get everything done at least 24 hours ahead of time. Just in your mind, just mentally say to yourself, the deadline, if the deadline's on Wednesday, the deadline's on Tuesday. And try to have everything done a day early, so if anything goes wrong, which it will sometimes, then you've got a day to make it up. So that, I personally, one of the reasons why I was successful in life, and now I'm a professor, I don't have to be. If I grade something late, what are the students going to complain? I mean, they wouldn't, but I'm kidding. But when I was working in industry and as a student, I would just try to have things done with at least, it depends on the project, but if it's a major project, I'd try and have it done 3 days before. If I'm working on a $5 million project, then I'll have it done a week beforehand, just in case, and there's plenty of time to go over it and revise and review and things like that. But for homework assignments, I would always shoot for a day before, and then if something went wrong, then I have that slack time of a day to make it up. And that philosophy went pretty well. So the peer reviews are due this Friday. They're due a week after your discussion, the original deadline. Yeah. So yeah. So procrastination, I get it. And in fact, if it's something minor, like if I have to write a letter of recommendation for a student or something, and they're like, I need this by Tuesday, and then I put into my calendar, write letter of recommendation for Bob on Monday, and I don't worry about it until then. I literally will procrastinate, and it doesn't bother me. Like I don't have that sense of procrastination of things hanging over your head, because like, yeah, I'll do it on Monday, and I just forget about it until Monday, and then my calendar pops up as like, write a letter of recommendation for Bob. I'm like, oh yeah. And I go into my email. Oh, there's the prompt. Knock out an essay, send it in. It's an hour out of my life, maybe. But, yeah, so procrastination in and of itself is not bad. It's bad if it causes you to actually miss deadlines. And that's when it's bad, or if you do shoddy work. And I'm not even picking on you. I'm just saying, like, you can make procrastination a way of life and be fine at it as long as you hit all your deadlines. You know what I mean? So, I was told we're going to go bowling the other day. I was going to work on it. Yeah. Okay. Yeah. So just, have a calendar, pop up alerts, and yeah. Okay. So a set, I could define a set any way you want. How about I define a set of all students in this class that procrastinate? And now you can rat out yourself on chat. Yes or no, are you a member of the set? The set of students who procrastinate, type Y or N, and then we can do a little bit of stats on it or something. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1 doesn't, 13 yes, 14, 15, 16, 17, lol, I assume is a yes, 18, 19, get the assignment by the due date. Yeah, that's it doesn't have anything to do with procrastination. Procrastination means putting things off, right? 20, yeah, so 20 to 1. So we can say 95% of the class procrastinates. Okay. And so that's oftentimes how you'll do a set. I worked professionally for a number of years doing this kind of stuff. I would have a set of all students, and I would determine which percentage of them did better on a second test after a first test and things like that. And no need to use explained terms you can understand. Let's call yourselves out. Yeah, like I said, like I don't even think it's wrong, Bailey. Like, if you get your work done on time, like, who cares? Like, what difference does it make? If you give me a deadline of, I was working with Reedley College in Reedley, and they said, all right, have this essay to us by November 12th. I'm like, okay. I put in my calendar, November 10th, start working on the thing, and then November 10th comes around, they're like, yo, we need that essay. I'm like, did I write the wrong date down? And I'm like, why are you hassling me? It's 2 days before the deadline. You told me the 12th. It's the 10th. I'm actually working on it right now, and it kind of irked me because like, why haven't you done it yet? Because you told me the 12th. You tell me the 12th. It's going to come to you by probably the 11th. That's the way it works, and I literally just don't worry about it until then. The big problem with procrastination is that you have this sense of impending doom because you've got all of these essays like just hanging over your head, And if you have a good calendaring system that you pay attention to that pops up alerts and things like that, then you just put it in the calendar. You just don't worry about it. All right, cool. I got the form. All right. November 10th. Bloop. Write the thing for Reedley. Okay. Sit down. Hour later. Done. Yeah. So, yeah, just the rule I have for myself is to never miss a deadline. And I'm very good about that. Like, in all of my professional career, like, I can think of maybe one time. I don't know. Yeah. Okay. 17th already. Yeah. Well, I got it done. I got it done on the 10th. But I was just like, why are you messaging me? I'm not late. Okay. Yeah, and if you have 5 projects due on the same day, then you have to start backing it up, right? So like if I look at my calendar, it's like AP Bio, whatever, write a report for this group, and I'm like, okay, that report's going to be 5 hours of my life. Okay, then I'm going to have to schedule this thing for the day before, and then I back it up, and then I knock things out one after another, like that. So you don't have 5 things on the same day. So you have to, I push everything to the last minute, move it back 24 hours to give me a gap, or more gap time if it's a major project. And then if I have multiple things, then they get backed up on top of that. And then I procrastinate and don't worry about it. I have 2 weeks. It takes me an hour to do it. I'm going to not worry about it. And it works pretty well. I meet all my deadlines, get my work done. It's fine. Nice. Okay. So a set can, I just formed a set of all students in the class that procrastinate. And this ties in with probability and statistics and things like that as well. So probability and stats. If I were to randomly select a student from this class, what are the odds the student procrastinates? 95%. Right? You write a schedule down but don't follow it. Yeah, that's the thing you need to work on then. Is you need to develop a sense of iron and steel in your soul that you actually, when the time comes, you sit down and you do it. And probably meditation would help with that too. Like one of the types of meditation I teach, and we'll be doing meditation probably this Sunday at 2:00. I'm trying to decide where it'll be because it's freaking cold the last time. I was freezing my ass off. But yeah, like meditation, like a focused meditation is actually really good for just like being able to sit down and knock something out. One of the biggest problems is just you sit down to do something and then you start checking email, you start checking the news, Reddit, whatever, Facebook, social media, Pinterest, whatever, and you get distracted and a 1 hour task turns into 7. That's one of the problems, right? 2 a.m. meditation, probably not. I would probably die. It'd be too cold. I had a yoga class last year that did meditation. It surprisingly helps. Yeah, it really does. And it kind of blew my mind, like, that, it does work. Because it seems just kind of like, I'm unlocking my chakras. But no, there's a lot of scientific research showing the benefits of meditation. Anyway, so yeah, I don't know of any place where it's like heated and outdoors, so I don't know if we like rented, a gym or I don't know, like it'll probably just be in the same place. I've kind of got no ideas on alternative places. Okay, so yeah, you just form a set however you want. Set of all students who procrastinate. Done. Everybody who, and then you give a survey to your class. You check yes or no. If they check yes, they're in the set. If they check no, they're not in the set. And that's basically all the set is. It's just a collection. In this case, it's a collection of students. Each student in the set is called an element. An element of a set is something that's in a set. And everything in the world, everything in the universe is either in that set or not. And so if the universe is students in this class, that's everything that exists, all the elements in the universe is students in the class. And I'm going to make a collection of all students who are procrastinators. Okay. And then I can make another set of like all students who are male and female is a common one, right? So set of all male students, set of all female students. And then there's going to be intersections and overlap with procrastinators, right? And so you can start asking interesting questions. And this ties in with computer science because sets tie in very much with databases. And databases are one of those common things we do in computer science. Like, you got a large data set. All right, is there a sex-linked trait here? Is it the case that more men procrastinate than women or vice versa? Right? And you can start looking at the stats that way. and if it is there substantial differences between the types of procrastination? You know, do men and women procrastinate in different ways? You know, what about non-binary gender people? How does that tie in with procrastination? And you start asking really interesting questions. So while all this stuff sounds like just like some strange mathy stuff, what it really comes down to, and what I really loved, I did this professionally for 12 years or so, is that there's a human story usually behind it, because you're trying to figure out something very human in situations like that. Like, why do people procrastinate? And if you have an intervention, like let's say you send, you know, half the students to a procrastination workshop and half of them are a control group and don't, and then you look at the numbers afterwards and you see the numbers go up in terms of like getting work done on time if they go to the workshop, then you can ask yourself, like, why was it effective? And was it more effective for men and for women? And there's actually a human story that underlies all this stuff. And you can use the power of math and computer science and analysis to actually figure out, like, what the hell is going on? And why was this intervention more effective for men than it was for women? All right? What, you know, was it because the speaker was a dude? All right, let's bring in you know, a female speaker next time and see if we get opposite results. Maybe that, oh, it didn't, okay, right? And so, you know, it all boils down, and humans are very interesting. Humans are very complicated and interesting. They really are. You know, as a computer science major, you probably are surprised that I say that, because computer science majors are supposed to be more interested in computers than people, but both are fascinating, you know. So he just got in procrastination. That's funny. Halfway through the class. So you can format a set any way you want, and then you can do analysis on it. And that analysis is usually, you know, from my professional career, it's usually a really interesting question. Why are people doing this? You know, and I would have data on 100,000 people, you know, and I would sit there and poke at the data and stuff. So if I have the set of all people living in America, okay, so the universe would be all people, let's say, and I would form a set of all people in America, and you're either in the set or you're not, right? So probably most of you are in America right now, although I wouldn't be surprised if some people were, like, you know, overseas and telecommuting to class, essentially. You know? Are you guys with me on this? Like, it's pretty open-ended. Like, you can just be like, the set of all people in this class who have an E in their name, right? So Jasmine, Brian Morales, Red, Bywater, Torres, you would all be in that set. Ashley would be in the set. But you're not in the set twice, Ashley Larson, because you have two E's, right? You're just in the set. You're either in the set, you're not in the set. Whereas, who would not be in the set if you don't have an E in the name? Joanna. All right, Joanna would not be in the set. She doesn't have an E in her name. Martin Calderon would be in the set. Vinan Tao would not be, right? So, who wouldn't take Kearney's class while overseas? Yeah, it was... I've had this one student in various classes, and she travels constantly. And so she'll be like, I'm in DC right now, what did I miss? And it's probably not good for your study habits. Or like I was calling on one of my students who's now a friend of mine. I'm like, hey, you know, what's the answer to this problem? He's like, hang on, I'm at Taco Bell. I'm in the drive-thru at Taco Bell. He's like, yeah, I'm in class right now. The person at Taco Bell's like, what? It's like, yeah, I'm in class. Just here's my money. All right, here's your bean burrito. You want hot sauce? Getting Taco Bell in class. I know, like, why Taco Bell? At least go someplace that's good, you know what I mean? Okay, so the terminology we use for sets, we usually use curly braces like this. So if I were to make a set of all cars made by Chevrolet in 1981, then it would include the 1981 Chevy Citation, which is the first car that I drove. And no, I'm not that old. It was just old when I drove it. Horrible car, by the way. You probably haven't seen many of these on the road, and that's because they are terrible cars. But my grandfather picked it up for me for $500. So, yeah. That was a great car to learn about cars on because it broke down constantly. So I'm like, oh, that's what an alternator is, as I need to put a new alternator into my car. 81 Chevy Camaro, So, taking in space field trip. It's funny. So, so you can form a set of all cars made by Chevy in 1981. Okay, but if you want to be a little more formal, then you use curly braces, and you kind of write it down this way. And you can kind of write them, down a lot of different ways. You can just say A. I often use just like big letters to represent a set. Set A is the set of all even numbers, and Z is integers. Have you guys seen that before? Z meaning integers. Seen that? What do you drive now? I do not still drive a Citation. Have you guys seen that before? Z? Integers? Okay. So if A is the set of all even numbers in Z, it's an infinite set, actually, because there's an infinite number of even numbers, right? There's 2 and 4 and -4 and 400 and -400. And you can just write that. That's a set. A is the set of all even numbers in Z. And then you can use this, which is something called set builder notation. And so let me read this to you, because this looks like hot garbage if you don't know what it translates to. Set B is defined to be the set of all elements X such that, the vertical slash means such that, set of all elements X such that X is an element of Z. So it's going to be the set of all integers such that X is greater than 42. So B is an infinite set also, and it's the numbers 43, 44, 45, 46 to infinity and beyond. All right? So a lot of things in mathematics look super complex and garbagey and hard to understand and cause your eyes to go crosswise until you understand how to read them in English, and then you're just like, oh, okay. Yeah, that's not hard. So this is just B is the set of all integers greater than 42. Okay. It's faster notation. Yeah, and that's why mathematicians use notation, especially back in the era before you have computers. It's much faster to just write things using symbols rather than writing, I'm going to sum up all numbers from 0 to 100. Now instead you write the little capital sigma, and they have all this strange notation. But after you understand, it's like, okay, you're just adding up all the numbers from 0 to 100. Okay. So this is set builder notation. B is defined as all elements X such that X is an element of Z, integers, and X is greater than 42. Set C is a heterogeneous set. It's not even integers or so. It's like on an integer. It's got a floating point number. It's got an imaginary number. It's got a negative number, and it's got Bob in it. So you can do that if you want. That's fine. Set theory is pretty open-ended in terms of how you can put a set together. And so are you in C? Probably not, unless your name's Bob. You're probably not a number, so you're probably not an element of C. You're probably also not an element of A or B because you're not integers. So this is something that Ashley was talking about on the Help Center, which is the absolute value bars. So I want everybody to pay special attention to these absolute value bars, because this is what causes more people to get quiz questions wrong than anything else. Where's my... There we go. I want everybody to take a moment and pay attention to that. The absolute value bars, when doing set theory, is not absolute value, because it's math. In math, they use symbols and terminology confusingly. Number of times, I've seen a little epsilon. Physics, math. What is I? Like a lot of these symbols get reused, and that just makes everything extra confusing for students. And this thing right here I want everybody to pay attention to that. In set theory, the vertical bars mean size of the set. That's what it means. You'll see the Zai books say the cardinality of the set, which sounds like a bird or something, right? You might hear from the disgust in my voice that I'm very much anti-jargon. I very much believe in trying to make things easy to understand. I'm not here to flex on you and be like, the cardinality of the set, just so I can like feel superior to all of the peons in my class. Nah, hell no. I'm here to make you guys learn. You know? I'm here to take the textbook and just pack it into your brain, you know? All the learning points, just get in there, you know, and test, you know, just and have you guys understand it. Because this set theory business is actually really important. You know, if you're a lawyer, you know, we're going to talk about, you know, the people who are going to bring a lawsuit are a subset of the people who are offended by it. You know, like the terminology, like set theory underlies all of mathematics. Set theory is the foundation of modern mathematics, and you use it in medicine and law and education and computer science. Like, you know, it's one of the most important foundational things. And unfortunately, the only real obstacle is that the terminology just looks really weird. You know, so. Yeah, you're welcome. Yeah. What was the, yeah. I'm literally not here to try to make myself feel superior to students. You know, I mean, I am. I'm messing with you. I'm really not. The point of education is to teach, in my opinion. A wild notion, but yeah, the notion is like try to explain things as easily as possible, and then after people get tired of writing, you know, something like this, you know, they're like, maybe, you know, they're like, hey, professor, is there a more compact way that I can write this? I'm like, yes, there is. You know, you can write it like this using set builder notation, right? So it's really important, you know, to, you know, especially if you become a teacher, which is to explain things simply and get people doing it, and then after all that, then you introduce the terminology. So like when you get tired of like, what is the size of C, right? And then all the students in this class will count. So everybody, please on chat, count how many elements are in C. Okay, there's 4, 6.2, 11, 9, negative 15, 5. Right? If you kiss up to your teachers, you can get a good grade. I see. Oh, that's the thing. Okay. So, what is the size of C? I'll ask you guys. What's the size of C? Yeah, and it bugs me too when professors give grades based on whether or not you agree with them. Motivated reasoning, right? Any student who disagrees with me must be wrong. So unless you make a damn good case for your professor being wrong, they will mark you down, right? Or they might be more open-minded, hopefully. Yeah, super annoying. I consider it academic malpractice. We should not be trying to stamp out clones of ourselves, right? My goal isn't to get you guys to agree with me, right? The goal is to give you the tools of thought so you can make your own decisions and come up with educated decisions. Yeah, and so the size of C is this. C with vertical bars with the absolute value bars around it. That's asking how many elements are in C. Okay? And I've seen some Rate My Professor reviews for political science professors, and a lot seem biased, yeah. Yeah. It's an issue that's gone a lot worse in the past 50 years. They do these surveys of like the political orientation of different fields in academia, and social psychology went from about 60-40 Democrat Republican back in the 1960s, if I'm remembering the stats correctly, to it's like they were at a conference of like 1,000 people, and the guy on stage is like, all right, if you're Republican here, put your hands up, and like 3 people did out of a crowd of 1,000 people. Now some of them might have been intimidated, but that also kind of makes the point. You know, so Yeah, there's a paper by a guy named Duarte and yeah, so there's all sorts of papers and stuff. Yeah, this one is a really good paper, and it goes through the cost of it too. You know, like how does that harm the field of psychology? Well, topics that are of interest to Republicans get neglected, right? And it's not like they're wrong. It's just they're different topics they're interested in, and so they just get neglected by the field. And they run and none of the authors are Republicans. That's the best part of it. Like none of them are Republicans, but they're like, look, you know, there's a problem. Like when the academy is so biased, they won't even hire somebody because like then they go into hiring discrimination where they literally won't hire a Republican and things like that. Like it's a real problem. It's a real problem. Okay, so anyway, let's make another set. So let's make a set here called D, and D is equal to 1, 2, 3, 4, 5, 6. So if I said the absolute value of D, it's not absolute value, it's the size of. The size of D is what? How many elements are in D? I tried that and failed. She's so angry all the time. Yeah, how many elements are in D? Count them. Ad hominem. How can you find interest in X topic when Y a political person likes it? Yeah, yeah, and there's a lot of tribalism too. Like if I worked in the history field for a number of years, and if you cite a professor that is of the wrong political alignment, then like you won't get a grant. You know, so there's a very systemic problem in a lot of these academic fields. Engineering, computer science is not as bad. It's becoming more politicized though. Computer science, there's active work for people to start politicizing computer science, and there's 6. Yeah, there's 6 elements. Okay. And so we can say the size of D is greater than the size of C. Okay. You guys understand the absolute value bars? That's this thing right here. That's the terminology that like legitimately causes most students' brains to explode because they're used to thinking of it as absolute value, right? Like the absolute value of -5 is 5, right? It's not. It's the size of because they reuse terminology. Okay. So what is the size of A? So C weighs 5. The size of C, the cardinality of set C is 5. There's 5 elements in C. Okay. So absolute value of C, it's not absolute value. It's the size of C is 5. Okay. It's infinite. Yeah. So like on canvas, there's no infinity symbol. So I just have you type in -1, or something like that. It's just indicate it's infinite. Okay. You guys with me on that? So like, if I ever ask, what's the size of B? How many integers are there greater than 42? Yeah, so on Canvas, I'm just like type in -1 for infinity. This is not good math. Like don't don't go to your like math instructor and said, my computer science professor said that infinity is the same thing as -1. No. No, I just have you guys type in -1 on Canvas because there's no infinity symbol. Yeah, I could have you type in 0, 0 or something. I don't know. There's no infinity symbol on the keyboard, so yeah, it's just a limitation in Canvas, right? So, why is A infinity? Because there are infinite integers, right? There's no maximum integer. If you give me a maximum integer, I will give you that same number plus 1, right? So if you try telling me that there's a maximum even number, I will give you that even number plus 2. If you say the biggest even number of all of them is 10, I'm like, well, what about 12? Right? So it's infinite. Yeah. And b is infinite also. Right, so b is infinite also because there's infinite numbers above 42. The highest number is 1,000. Okay, well, what about 1,001? I'll have a note on the question. Yeah, you don't have to memorize this. On the quiz question, it'll be like, if the answer is infinite, type in -1. And that's just to deal with the limitation in Canvas, because there's no infinity symbol. So two sets have the same size if they have the same cardinality. If you take the size of L, this is set L over here, how many elements are in L? There are 5. There are 5 leopards. And now, without counting the number of sheep, let's try this trick. Without counting the number of sheep, you might have done it already, but just pretend like you're not going to count the number of sheep. If I tell you that for every leopard, there is 1 sheep in S, right? There is a 1-to-1 and onto correspondence between leopards and sheep. If I say for every element in L, there's an element in S, how many elements are in S? How can you not count if you can see it? Put your hand over the screen, and I'm just going to tell you that for every leopard, there is 1 and exactly 1 sheep, and none of the sheep are missing a leopard, right? There's a 1-to-1 and onto correspond. For every leopard, there's a sheep, and vice versa. How many elements are in S? Trust me, you didn't count. If there are 5 leopards, then there must be 5 sheep. That's correct. So this is an alternate way of counting. So you can actually, like, if I were to obscure this set and just tell you every leopard corresponds to exactly 1 sheep and vice versa, how many sheep are there? You could be like 5. Right? 2 sets are the same size if you can define a 1-to-1 and onto correspondence, a mapping from one to the other. Okay? So here's a question for you. So we're almost out of time. We are out of time. Are there more even integers? What's bigger? The number of even integers? Is it greater than, less than, equal to the number of integers? Are there more even integers or are there more integers? Which infinity is bigger? The number of integers or the number of even integers? Now our intuition is going to say, well, there's obviously more integers, right? Because there's both even integers and odd integers, right? So there's more of them. It is a trick. It is a trick. They are actually the same size. This and this are the same size. And the reason for that is because you can do a 1-to-1 and onto correspondence between the integers 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12. For every integer in Z, this is Z, this is the evens. For every integer in Z, there is exactly 1 integer in the evens. Therefore, by this rule here, they're the same size. So, yeah, when you start dealing with infinities, like, your brain should like kind of melt and start leaking out of your ears if you're doing it right. Because infinity is a very hard concept for the human brain to wrap itself around. But this is more of a curiosity than something you really need to worry about too much. But yeah, there's the same number of even numbers. There's the same number of odd numbers. And by numbers, I mean like integers. There's the same number of positive integers as integers. There's the same number of negative integers as integers. If you ask What about the set of all integers divisible by a million? So 1 million, 2 million, 3 million, 4 million. It's the same size. The number of numbers divisible by a million, it's exactly the same size as the set of all integers. And then your brain just goes. This comes out of your ears, runs away, doesn't come up. Yeah. So somebody posts the gif of the brain, like the guy going like. And we'll just call it here. So your quiz for today. Z is always all integers. Yeah. This is a standard term in mathematics, and I tend to write it like that. And so this is the set of all integers: 5, -10. No fraction. I mean, no decimals, right? Like not 5.4. Integers are whole numbers, positive, negative. There it is. Thank you, Brian. So on the quiz, I'll just make a couple sets and ask you to compute the size of it. Okay? Make sense? Oh, and then if you're going to do an interval, I guess we should review that. So this means the interval from all numbers from 0 to 10, including 0 and 10. So this is 0, 1, 2, 3, ... 7, 8, 9, 10. And if you draw it with parentheses, it means the set of all numbers from 0 to 10 without including 0 and 10. So it'd be 1, 2, 3, 7, 8, 9. Have you guys seen this before in algebra? Like the square bracket means it includes the number, and parentheses means it doesn't include the numbers listed there. And you can do like the half open pattern where it's like the set of all numbers from 0 to 10, not including 10. It's like a smooth parentheses there. So that's 0 through 9, basically. Alright, so that's it. That's for today. Set theory is actually really relevant to your life and careers and things like that. So hopefully I'm explaining in such a way that I'm not too jargon heavy. This aside, that's mostly I just do that to screw with my students because it's so funny. Okay. Like what? It blew my mind when I first heard it too. So I always try to talk about the different infinities just because it's fun and it's funny. Okay, so that's it for today, and I will see you guys on Friday. Make sure you get your peer reviews done and start working on the Zybooks. We'll talk more about set theory. That'll help you with the Zybooks also because the Zybooks is on set theory. So, all right, peace out, everyone. Have a great day.